Ladies and gentlemen, thank you very much that you have given me the time to give you some insights on our semi-hermetic ammonia compressors in this ungodly hour when everyone is about to fall asleep. I would like to talk a little bit about the trends in the industry, which are green and cost-effective. The changes within our HVAC and refrigeration industry are actually accelerating. Ammonia, propane, and CO2 are the only long-term refrigerants, keeping in consideration that we are just in front of a PFAS regulation which will ban the HFOs. The cost pressure, especially now, is accelerating with our current economic situation in Europe, which for sure will also spread out in the surrounding areas. Heating and cooling are the two sides of one coin. We are removing heat out of one room and put it into another. But to push this energy into the atmosphere is ecological and economical crime and should be not done. We should utilize that energy, by example, heat pumps. So a holistic approach is now changing our industry in the applications. We do not just make something cold. We utilize this energy. We integrate heat pumps into projects, thus mitigating climate change as much as we can. Also, the borderline of commercial and industrial refrigeration is getting blurred. It's not a clear cut anymore between commercial and industrial. I believe it is much more now becoming a differentiation between commercial CO2 application with gas cooler, ejector technology, transcritical, and contractors who are doing the industrial refrigeration in ammonia and propane. The features of commercial refrigeration are integrated into industrial compressors. When in previous times an industrial compressor was just a bare shaft block, now more and more it is integrated, control components, solenoid valves, differential pressure switches, sensors, filters, and it is changing also the design of our industrial compressors. Compactness and versatile installations are key. Space is premium, it costs money. On-site cost is something we all try to avoid. Labor cost on site is one of the biggest cost drivers in the life cycle cost, and this is not only in capital investment, it's also in the service cost. And of course, the main driver of our whole economy is energy. Energy as such, but also, of course, to provide and use energy which is done and generated by environmentally benign sources. All natural refrigerants are somehow potentially dangerous. We talk about flammability of propane. We see, of course, also the toxicity of ammonia, but also the high pressure of CO2. The result of all of that is we have to die one death. If it is clear that we utilize natural refrigerants, there is no way out of it. So we need to die one death. Our governments are helping in that. Yeah. When we see how the legislation has changed in the last couple of years, from very strict refrigerant charges, when we talk about propane, now they are lifted. And it is all possible. Plant room requirements are also changing and are getting unified within all of these refrigerants. So there is not a reason anymore to apply or not to apply due to legislation. Of course, it is clear I like ammonia. The properties of ammonia are very obvious. It's non-ozone depleting. It has no direct global warming potential impact. It's a long-term natural refrigerant, and it has got a refrigeration efficiency, which is as good as R-22. Last but not least, the chemical companies will not like to hear that, but it comes with a low price. The only downside I see is the high enthalpy difference makes it a bit difficult to control when we talk about low capacity systems. The flammability and the toxicity is actually not such a big deal anymore. We have to just follow the safety precautions and the dedicated plant rooms which cannot be entered by other people. A little bit of a problem can be the oil miscibility, especially for contractors who have to convert from freon and these refrigerants where the oil is on the top to ammonia where the oil is on the bottom. We all know that ammonia and copper do not like each other, so semi-hermetic compressors are a bit of a challenge when they are suction gas cooled. This is something which has to be seen, and you need to have workable solutions. Steel piping instead of copper makes the whole thing also a little bit more expensive and less easy to install. What I can see is that ammonia is applied fast in many applications. And it is also applied in many smaller capacity applications, quicker and quicker. The skills in the industry are not keeping up with that. They are not spreading at the same speed. And we all see that as a main obstacle to install, to service, to keep ammonia systems going. So, we were aware of this situation. And we have developed semi-hermetic compressors called SRS and SRS-C to support the industry to apply it in an easier way. It has got no shaft seal, which makes it easier in the commissioning phase. You don't have to align the shaft of the motor and of the compressor. It makes it easier later on in the service. You don't have to change it. You don't have to do the regular maintenance on it. And there is no danger of drying up, especially in applications which are seasonal. So, for example, an ice rink, which is operated from August until March, and in the meantime it is idle. How often can it dry up? And when you start up, you have a leakage. So we have a technical, permanent, leak-proof compressor. The problem with the copper and the ammonia we overcome by using permanent magnet motors with aluminum windings. Of course, you could also use copper windings and insulate them. But if you use aluminum, you avoid the problem of an insulation which is getting somehow cut. Of course, copper has a higher efficiency than aluminum. So if you just use aluminum, you end up with a goddamn big motor, which nobody wants to have. The solution is to use a permanent magnet motor, which is reducing the size of the motor again, and you have a highly efficient motor. And that's what we did. Our motors can be operated in a speed range between 1500 RPM and 4200 RPM. That provides you with a large range of capacity, part load capacity to follow your demand of cooling. The model range we have got is from displacements of 43 to 709 cubic meters per hour on single stage single compressor applications. Oil separators, which we have got, and they are matching to the compressors, make frames obsolete and reduce cost. Cost in steel, but also cost in mounting, in welding, which all in the end adds up. We have got a wide range of double-stage compressors for low-temperature applications as well, semi-hermetic. And with our SRSC, like compact or like chiller, we have a compressor which has an integrated oil separator. So we went one step ahead. This, again, is reducing cost of the oil separator, of the piping up, of the welding, and of potential leakages. So this is our range of SRS, semi-hermetic, single-stage screw compressors. You see they come with a whole lot of features like the solenoid valves, the oil filters, the pressure differential switches, and sensors. And they can easily be mounted onto horizontal oil separators. They are very compact and very versatile, so you could use between single compressor applications, double and triple packs. They can be even compressors or uneven compressors. So you could have a very small one for your weak and low capacity demand, and a big compressor which is then added for the operating during the week. We have these compressors now in operation since more than 8 years. We're working them on more than 450 compressor packages meanwhile, since more than 8 years. And it is a stable solution, stable motors, which are working reliably. Same thing can be said, just in lower volume and numbers, on the low temperature applications, double stage semi-hermetic compressors. More than 110 compressors are applied meanwhile since 2017. Again, very compact solutions. The only downside of double-stage compressors is compared to a booster system that you cannot apply a side load on the high temperature side. So it is the right solution for dedicated compressor systems to one blast freezer, one spiral freezer, for example, or one low temperature cool room without a side load. Now I come to our newest baby, the SRSC, which is a compressor with the integrated oil separator. This compressor was introduced to the market with one model in the year 22. We have more than 40 compressors applied, mainly in Denmark and in Germany. It comes with integrated temperature sensors and liquid injection ports, so that we can also now do air-cooled and dry expansion systems and have these liquid injection ports as emergency cooling systems for the very hot day and the high condensing pressure. The integrated oil separator means it is less piping needed to be integrated, less welding, means less welding potential leakages, less space needed, and finally, the main driver, less cost. So I believe this is the ultimate screw for chillers. I have to say that in these compressors, it is a two-stage oil separation. So the oil throw is higher than on three-phase oil separators. The oil separation is done here by centrifugal forces and demister, and the carryover rate is something between 30 and 50 ppm. So it is very clear 30 to 50 ppm is not good enough for long piped several room cooler systems. It is the right solution for chillers, closed circuited systems where you have an evaporator close by and you have an oil return system with a drop leg or an ejector system. So it is for chillers. As we have learned our lessons during COVID with the interrupted supply chains and the long lead times, we have thought about that, and after our production capacity in Asia is fully utilized, we have now also started to produce these compressors in Italy. So we have made in Europe applications, compressors, short lead time. We have the technical support on hand and available, spare parts available, and I believe now we have a strong support for the industry to apply these compressors with direct support and help. So I believe, as a summary, we now have got tools where we can apply ammonia safely and easily in compact and flexible ways, where we can apply up to 1.2 megawatt of refrigeration of -10 and condensing of 38 in a very model series which is available at your fingertips anytime. So I thank you very much, and I'm open for questions and answers. Have I killed all potential questions? This is fantastic. Then we can go to the happy hour now. And if you are keen for some drinks, please join us at the stand party, which is happening as soon as I'm back on our stand around the corner. Please enjoy, and thank you very much.